Welcome to this video. So in this video, we're going to learn how to sketch exponential functions in an easy way. Okay, so in general, an exponential function is represented as f of x is equals to a to the power bx plus c, okay, and then plus d. Okay, so these letters A, B, C, they mean something. So let's talk about their meaning. Okay, so this guy here, the base, the A here, this A, which is being raised to a certain power there, is what we call as the base. Okay, this guy here, the D, is what we call as the horizontal asymptote. Okay, and then these guys here in the power, okay, they're going to help us, okay, to find what we call as the y-intercept. Okay, so these ones here is going to help us, okay, help in finding y-intercept. Okay, so when you're sketching exponential functions, you only need to know only need to know these three things that I've indicated there. Okay, you have to know your base. Okay, you have to know your y-intercept, and you have to know your what? Your horizontal asymptote. Okay, you have to know your horizontal asymptote. So the base, depending on its value, okay, is going to give you either a type 1 graph or a type 2 graph. Okay, and then the horizontal asymptote will just be a horizontal line that this curve will never touch. Okay, so it will just be going closer and closer to that line, but it will never touch it. Okay, so let's start with the base. Okay, so the base uh, determines what type of exponential graph we have. So we have type 1, and then we have a type 2. So type 2, okay, so for type 1, the base A has to be greater than 1. So it can be 1.5, okay, any number that is greater than 1. Then we're going to say that that's exponential equation will have a type 1 graph or a type 1 sketch. And then if A is between 0, okay, and 1, meaning any number that is greater than 0, but it's less than 1, like 1.5, okay? I mean, not 1.5, but 0.5, 0.3, 0.6, all those numbers, okay, that are between 0 and 1, if that's the value of this A, then we're going to have a type 2 graph. Okay, and then this D, I said, is just the horizontal asymptote. So we're just going to plot a horizontal line that this curve should never touch. And then this power here is going to help us find the y-intercept. Okay, so for example, if I have this question here on number A, okay, so I have two, let me write it like this. I have f of x is equals to 2 to the power x. Okay, so let's identify these key three things that we discussed here. First of all, my base here is this 2. Okay, we see that 2 is greater than 1. So I have a type 1 graph. Okay, and then this power here is going to help me find the what? The y-intercept. So how do I find my y-intercept? Okay, I always set x to be equals to what? To 0. And then I solve the equation. Okay, so this one here will just be f of 0, that's the y-intercept, is going to be 2 to the power 0, which will just be 1. So the y-intercept is equals to 1. So meaning that the curve should pass to the point 0, 1. So 0, 1. So that's the y-intercept. The other thing that we need is the horizontal asymptote. Okay, so this equation here is 2 to the power x, and then plus, there's nothing here. Okay, there's no plus anything here. So if there's no plus anything here, it simply means that the horizontal asymptote is going to be what? 0. So horizontal asymptote would just be y is equals to 0 for this guy here. And then let's plot it. Okay, so this is my y, and then this is my x. So the point that I need is 0, 1. 0, 1 will be somewhere here. Okay, so I can plot it like that. And then my horizontal asymptote is y is equals to 0. Okay, because this 2 to the power x is not added to anything here. We said the horizontal asymptote is what you add to this base to the power something, right? Okay, so let's plot the horizontal asymptote. It's just y is equals to 0. Y is equals to 0. It's the same as the x-axis. Okay, so I'm going to just plot a dotted line just above the x-axis like that to indicate my y is equals to 0, which is my horizontal asymptote. So when I sketch this graph, okay, it should not touch that that dotted line, but it should be getting closer and closer to it. Okay, so for a type 1 graph, okay, for a type 1 graph, the graph always starts from below here, and then it goes up like this. Okay, passing through the y-intercept like that. Okay, so that's a type 1 graph. And then if we had a type 2, okay, for example, we had 1 over 2, and then to the power x, okay? So we see here that the base will be 1 over 2, which will be less than 1, and it's greater than 0. So this will be a type 2 graph, okay? So when I find my y-intercept, it's still going to be 1, okay? Because half to the power 0 is also 1. Okay, so here to be half to the power 0, which will still be 1. So my y-intercept does not change, okay? It's still there. But for a type 2 graph, it always starts from the right here, okay? And then it goes up like this on the left. Okay, so you are seeing that these two graphs, they're not touching this horizontal asymptote here, okay? But for a type 2, it starts from the left here, and then it goes and passes through the y-intercept, goes to the, it starts from the right, goes and passes through the y-intercept and then goes to the left. And then for a type 1, it starts from the left and then goes and passes through the y-intercept, goes to the right. Okay, so this one here is a type 1. And then this one here is a type what? 2. Okay, so now one graph, or I can say a type 1 graph can become a type 2 graph, and a type 2 graph can also become a type 1. So when does that happen? Okay, so when I go back to this, my general form, you've seen this power here. Okay, so if the coefficient of this x, which is this b, okay, so let's say we had a type 2, a type 1 graph, okay? Let's have f of x is equals to 2 to the power x. We see here that the base is greater than 1, right? So this is a type 1, okay? So now, when the coefficient, okay, of this x in the power becomes a negative in a type 1 graph, then it switches to a type 2. So meaning that if I have f of x is equals to 2 to the power minus x, okay? So now, the coefficient of this x is a minus. So this one, quite all right, the base is greater than 1. So this means it's a type 1, right? Okay. But because of this negative here, okay, because of the negative in the power, this graph switches and it becomes a type 2. Okay. So simply meaning that, okay, 2 to the power minus x, we have the graph starting from the right going to the left like this. Okay, why? Because this graph here in black, we had said it was 1 over 2 and then to the power x, right? So this 1 over 2 by the reciprocal is the same as 2 to the power minus 1. Okay, 1 over 2 is the same as 2 to the power minus 1. And then I have that to the power x. So when I multiply, I get 2 to the power minus x. Okay, so 2 to the power minus x is the same as 1 over 2 to the power x. So when the sign in the type 1 equation changes to a negative, okay, then the equation becomes a type 2 if the graph was a type 1. If it was a type 2, okay, for example, if it was like this, my f of x was 1 over 2 and then to the power x, okay, we see that this one here, because this base is less than 1, but it's greater than 0, okay, it's going to be a type 2, meaning it's starting from here, it's going like that. Okay, once I introduce a negative in the power, when it becomes like this, minus x, this here changes to a type 1. Okay, it changes to a type 1. Why? Because whatever is inside here, remember it's 2 to the power minus 1, this 1 over 2 is the same as 2 to the power minus 1. Then I have a minus 1 or a minus x outside. So I multiply minus 1 multiplied by minus x, I just get 2 to the power x, which is a type 1. Okay, so when I introduce a negative, okay, to an equation that was the type 2, if I introduce a negative in its power, okay, for the x, it changes to a type 1. Okay, so those are some of the things that you need to know in order to sketch these exponential functions. But the most important thing is to know the base, okay? And then you say, okay, this base is greater than 1, so this is a type 2. Or this base is between 0 and 1, so this is a type 2, okay? When the base is greater, it's a type 1. When it's between 0 and 1, it's a type 2. Okay, so once you know the base, you also have to know the horizontal asymptote. Okay, so the guy which we add to this base to the power something is the horizontal asymptote. Okay, and then the other thing that we need is just to find the y-intercept here. So how do we find the y-intercept? We always set x to be equals to 0, and then we solve the equation that we've been given. Okay, so now let's sketch this question that we've been given here. Okay, so we start from the first one, which we already sketched anyway, but I will do it. Okay, so f of x is equals to 2 to the power x. Okay, so the first thing we see that 2 is greater than 1. So this is a type 1. Okay, so it will start from the left and then it increases to the right like that. Or start from the bottom, then it increases to the top. Okay, so it's a type 1 graph. And then what else? It's not added to anything here. They are not adding anything. Okay, so meaning the horizontal asymptote is simply y is equals to 0. Okay, and then the other thing is to find the y-intercept. So y-intercept, always set your x to be equals to 0. So y-intercept will be equals to f of 0, which will just be 2 to the power 0, and this will be 1. Okay, so it means the y-intercept is at 0, 1. So let's sketch. So this is my y, this is my x, 0, 1. So 0, 1, it's here, I plot it. Let me plot my y, my horizontal asymptote, which is just y is equals to 0. So that is the x-axis. So you just put a dotted line above the x-axis like this. So since it's a type 1, it starts from here, passing through the y-intercept like this. So this is the sketch for 2 to the power x. As simple as that. Okay, let's look at B. So B, we have f of x is equals to e to the power x minus 3. Okay, so let's identify the base. The base is e. So e, okay, has a value approximately. Okay, so I was saying e is approximately 2.7 something. So we see that e is actually greater than 1. So this is a type 1, okay? And then let's find the horizontal asymptote. Okay, so we see that this thing here, e to the power something, has been added to nothing here. So it means my horizontal asymptote is just y is equals to 0. And then we find the y-intercept by setting x to be equals to 0. So y-intercept will be equals to f of 0, which will just be e to the power 0 minus 3, which will just be e to the power minus 3, which is the same as 1 over e to the power what? 3. Okay, so e is 2.7 something. So this is a positive number, and when I raise it to power 3, I'm going to get a positive number. So 1 divided by a positive number is going to be a number that will be less than 1. Okay, to be a number that will be less than 1. If you want, you can check on your calculator. You say 1 over e to the power 3 to be a number that will be less than 1. But we don't even have to find the exact value there. So this is my y, okay? And then this is my x here. Okay, so my 1 should be somewhere there on top. This 1 over e to the power 3 should be somewhere below 1. Okay, my horizontal asymptote is still the x-axis. So I just draw a shaded line, okay, on top of the x-axis. And then since this is a type 1, then starting from here, passing through this y-intercept here that we found. So like this. So this is the curve of e to the power x minus 3. Okay, so we are done with that. Let's look at C. Is it B again? The numbering there was not okay. Okay, so I'm sketching this one here. So that is f of x is equals to 3 to the power minus x. Okay, so now remember what we said when we have a negative x. So 3 is greater than 1. This should be a type 1, right? But the power there is negative, so it changes to a type 2. Okay, and then the horizontal asymptote will still be y is equals to 0 because this thing is being added to nothing. What about the y-intercept? So the y-intercept, we will say x should be 0. So y will be equals to f of 0, which will just be e to the power 0, or minus 0, which will just be 1. So the y-intercept is at 0, 1. So now if I draw my y, my x, okay, this is 0, my 1 should be somewhere there. Okay, I draw my horizontal asymptote just above the x-axis, like this. Okay, and then I'm coming from where? So now this is a type 2, so I'm starting from here, and then I'm moving, I'm starting from here, and then I'm moving like this. Okay, so here, this is the curve of 3 to the power minus x. Okay, let's look at part C now. Part C, it's this one. We have f of x is equals to 5 to the power x plus 2. Okay, as per usual, the base is 5 greater than 1, so this is type 1. Okay, the horizontal asymptote is still y is equals to 0 because this thing is being added to nothing. And then I find my y-intercept by always setting my x to be equals to 0. So my y will just be f of 0, which will be equals to 5 to the power 0 plus 2, which will be 5 to the power 2, which will just be what? 25. So my y-intercept is at 0, 25. Okay, so I'm going to sketch my y, sketch my x, okay, and then this is 0 here. So this is 1 somewhere here, 25 should be somewhere there. Okay, so my horizontal asymptote is still y is equals to 0. So just draw a shaded line above the x-axis like that. So since it's a type 1, then it's starting from here and then going like this, passing through the 0, 25 like this. So this guy here is my 5 to the power x plus 2. Okay, let's look at D. So D, we have f of x is equals to 7 to the power minus x plus 3. So 7 is greater than 1. This should be a type 1. Okay, but it's changing to a type 2 because this x has a negative coefficient. So this is type 2. Okay, horizontal asymptote is still y is equals to 0 because this whole thing here is being added to nothing. Okay, my y-intercept is when x is equals to 0. So this will be y is equals to f of 0, which will just be 7 to the power minus 0 plus 3, which will just be 7 to the power 3. Okay, so 7 to the power 3, it's 343. Okay, but you don't really have to find this in case you don't have the calculator. You can just plot the 7 to the power 3 on your y-axis. So this is my y, and then this here is my x. Okay, so my horizontal asymptote is still the x-axis, or y is equals to 0. So this is 0. And then my y-intercept, if this is 1, it's somewhere at 343. So it's there. Okay, so now this guy is a type 2. So it starts from here, and then it goes and passes through the y-intercept like this. So this guy here, okay, is our 7 to the power minus x plus 3 sketch. Okay, let's look at part E. So part E, okay, we have f of x is equals to 4 to the power x and then plus 4. So here we're saying 4 is greater than 1. So this is a type 1 graph. Okay. The horizontal asymptote now is equals to 4, because to this 4 to the power x, they've added a 4. So whatever they're adding there, that's the horizontal asymptote. So for these ones here, there was nothing that was being added. So we were saying the horizontal asymptote is 0, 0, 0, 0. But for this one, the horizontal asymptote y is equals to 4. And then we now find the y-intercept by setting x to be equals to 0. So this will be y is equals to f of 0, which will just be 4 to the power 0 plus 4. 4 to the power 0 is 1 plus 4. This will be equals to 5. So my y-intercept is at 0, comma what? 5. Okay, so let's sketch now. So this is my y. This is my x. Okay, so the horizontal asymptote is at 4. So if this is 1 somewhere there, 4 can be somewhere there. So the horizontal asymptote is at 4, like that. So that's my y is equals to 4, my horizontal asymptote. Okay, and then my y-intercept is at 0, 0,5. So 0, 0,5 can be somewhere there. Okay, and then this is a type 1. So it's coming from there, passing through there, going like this. So this guy here is my 4 to the power x and then plus 4. Okay, so that's the sketch there. Okay, let's look at the last one for these exponential sketches. So the last one is f of x is equals to 5 to the power x minus 2. So 5 is greater than 1. So this is a type 1. Okay. The horizontal asymptote is whatever they are adding or subtracting to this 5 to the power x. So that is y is equals to minus 2. Okay, and then I find the y-intercept by setting x is equals to 0. So y will be equals to f of 0, which will just be 5 to the power 0 minus 2. And this will be 1 minus 2, which will just be minus 1. So the y-intercept is at 0, minus 1. Okay, so let's draw x. This is 0 minus 1 somewhere there. So the horizontal asymptote is at y is equals to minus 2. Okay, so it's there, like that. Okay, so that's the horizontal asymptote, y is equals to minus 2. And then this is a type 1. So I'm starting from here, okay, and then I'm going like this. So this curve here is for 5 to the power x minus 2. Okay, so we are done with sketching exponential equations. So it's very simple. So remember, you just have to know the type, okay, from the base, and then you calculate the horizontal asymptote, and then you calculate the y-intercept. Okay, and then once you have these three, it's very easy to sketch any exponential function. Okay, so thank you so much for watching this video. This question, I got it from tutorial sheet 4, this one here. So tutorial sheet 4 has questions on logs and exponentials, as well as questions on trigonometry. Okay, so if you like to access the full video solutions where I was solving all these questions, okay, so all these questions here have been solved already and they're there on our website. So you can actually access the full videos to these questions here, okay, by just registering on our website as well as our mobile app. Okay, so check the link in the description below. Okay, you'll find a link to our website, to our app, and a link that guides you on how you can register and access the full videos to these questions that you can see here. So you can learn at your own time, at your own pace, anywhere, even in your what? Even in your blankets. Okay, so once you register and then you come on our website, you're going to see something like this. Okay, so you register for the course that you want. If you want chemistry, you register for chemistry. If you want math, physics, biology, anything that you want. Okay, so for example, if you register for math, okay, you should see enrolled on the corner there. So you open the course. Okay, once you open the course, you go to general mathematics. Okay, and then you're going to find 4 folders here. So here there are lessons and tutorials on each and every topic that you learn in math. Okay, here there are handwritten summarized notes. Here there are tutorial sheets and assignment solutions. And then here you have the past papers, the quizzes, the test, and the exam paper. You'll find them here. Okay, so if you want to access the tutorial sheet, you just open this folder here for the tutorial sheet. Okay, and then there are different universities, so you go to your university. Okay, so you can go to university there. Okay, so once it loads, you're going to find different intakes if you are from Apex. Okay, so you can go in the 2025 July intake. And then you're going to find full videos for all the tutorial sheets that you've had. So tutorial sheet 1 on set theory, rational and rational numbers, full videos are there. You can watch at your own time. Okay, learn at your own pace. Tutorial sheet 2, full videos are there. Tutorial sheet 3, full videos are there. Tutorial sheet 4, where I got the question that I was solving just now. Okay, we have uploaded all the videos there. So you can access them and then learn at your own pace, at your own time. Okay, so thank you so much for watching this video. All the best as you prepare for your test, for your quiz, or for your exam.